we can, what is SNMP, what is the use of it, why we need that, and things like that. So now today we'll be looking upon the different models that we have in SNMP. The topic for today is SNMP models. So you have organization model, information model, and structural model. So first today we will be seeing organization model and little bit about information model. The remaining will be seen in the next class. So to start with, so SNMP model is nothing but your SNMP, you have manager and agent. So manager will govern the different objects that we have in the network. So objects in the sense the different components or different devices that we have in the network is being managed by the manager, and agent is nothing but the different devices that we have in the network. So we call them as managed object. So they are being managed by the manager. So manager and agent are nothing but softwares which reside on your managed object such that it is able to do its work. So they are nothing but software that is written onto the device such that they act as the manager and they can act as the agent. So they how they interact with each other is by using some message communication. So they just the manager can query some details that is required by it, and the agent will respond to it. So they behave like a client server like architecture. So we will be looking about what are the managed objects and what is the rules for SMI. SMI is structure of managed information, and then about the virtual database MIP. So first, this is your first model, organizational model. So what the organizational model says is, it will tell you how the manager and the agent are organized in your network. So as I told you, you can have a manager which governs the different components on your network. So these components, we call them as managed objects. So these agent, they can be managed by the manager. So if you can have as a two-tier organization, or you can have it as a three-tier model. So if it is a two-tier model, we will have one manager and you will have n number of agents. So this forms a hierarchical structure. So your manager will manage the different agents that are available in your network. Suppose if we have more than one manager, then it becomes a multiple manager organizational model. You can also have a three-tier model. So first I'll tell you what is a two-tier model. So this is an example for the two-tier organization model. So you will have a manager and you will have n numbers of agents. So you can have one manager to one agent, or one manager who manages n different agents. So in a network, you will have n number of components which allows us to transfer the data in a smooth manner. Suppose if you have two managers to govern the different components in your network, so then this becomes a multiple managers. Why we need this multiple manager? A manager can govern n number of devices, right? So a manager can govern 5 devices or 4 devices or 10 devices or hundreds of devices that are available in a network. Then why do we need this multiple managers, more than one manager? Why? Because it is depending on the device, that is the vendor of the device. So one vendor will be capable to do that it will be able to manage much better than the other manager vendors that we have. For example, a Cisco can do a good managing capability when compared to 3Com vendor. So this Cisco, 3Com, these are vendors which create your network components. So a Cisco vendor will have a better management softwares than compared to the 3Com. So we can have multiple managers where these managers can be managed by a single network management system. So you can have more number of managers so that the management thing is done in a better way, and you will have one network management system which will govern the different vendor managers that we have. So that is the main aim why we need multiple managers. So one manager, for example, of a Cisco is good at managing for example, a hub-like kind of a device. For example, a manager which is from a three-com vendor, it is good to manage only the devices that are connected, like the printer and small scale devices. So you can have these kinds of managers. The managers can be different. Okay, so you need one network management system which will govern, which will look upon into the different managers you have. So that is the main aim why we need multiple managers. So as I told you, we can have one manager that can manage n number of devices, or you can have more number of managers. So why do we need more number of managers is depending on the vendor. Okay, depending on the vendor, the manager can have, that is, you can have more number of managers. So this is one example that depicts one manager, one client model, and multiple managers, one agent model. So this is about your two-tier organizational model. So as I told you, a manager and your agent will communicate with the help of messages. Remember the 5 different messages that I told you in the previous class. Uh, get request, get multiple request, set request, trap, all those things. Okay, so with these messages only your managers and agent will communicate with each other. It is just like querying. Okay, you are doing some query on a database, you get some information. So what kind of information you will get is the type of the device. Okay, what kind of device it is. Remember the table that I gave you in the previous class. So you have that system ID, system information, how much time the system is running on without any down, okay, without any problem, how much time the system is running on. So I gave you 2 examples. One hub was running for 286 days, if you could remember, and another hub was running for 36 days. So these kind of information is what your manager will query on the agent. So how much, what kind of vendor it is. So one vendor was 3Com that we saw, and the router was the vendor from the vendor Cisco. And these are the you have some information which cannot be changed or which cannot be altered. So those information are pre-written by the vendor. That is the name of the vendor, what kind of software it is using, what kind of version it is. If you could recollect the things which I told you in the previous class, so this is what we were seeing. So manager will query on to the agent. So what he will query is these different things that he needs. So how much time the device is being running, how much, what is the vendor, so who, which type of software it is using, what is the version. So those things the manager can query upon the agent. So this is whatever I told you. This is about your two-tier organization. So why we need a three-tier organization? For example, assume that I want to monitor the traffic that I have in the network. That is number of incoming packets and number of outgoing packets. Okay, how much data that is coming into my network and how much data is going out from my network. So this thing should be done by the manager, right? Your manager will only manage all the components and all the things that is related with your network. So if I ask the manager to monitor the network also, okay, it is monitoring the devices and additionally I ask it to monitor the network of the device. So it becomes a burden on the manager. So a manager will manage the different components that it has got. So in order to, if I make it, if I ask it to monitor the device network traffic also, then it becomes a burden on the manager. So what we do is we then, in order to avoid giving more burden onto the manager, we have the three-tier organization. Okay, so in three-tier organization, what we do is you have the remote monitoring. So remote monitoring is used to monitor the network traffic. That is the number of incoming packets, the number of outgoing packets. So this will avoid giving more burden onto the SNMP manager. So that is where you have this three-tier organization. If you see in the two-tier, we had only the manager and we had only the agent. So now in three-tier, so when you want to do some additional work, okay, manager will do only managing of the agents. If you want to do any other work, for example, here we want to manage the network traffic. I want to identify the number of incoming packets and the number of outgoing packets that I have on my network. So to do that, I will have I will have a component which will do only the work of monitoring the network. It will not do any other work. So that is called as a remote monitoring. So this is how your three-tier organization comes into picture. So two-tier organization, you have only the manager and you have the different agents. So these agents, we call it as managed object. So as you can see in this figure, so RMON, so remote monitoring is inserted between the managed object and the network manager. So this becomes a three-tier organization model. So next, like how I said in the previous class, your SNMP can manage SNMP object and it can also manage non-SNMP object. So how I say that it is SNMP managed object is it will be specified in your request for comment documentation. Okay, it will follow the RFC standard that we already saw in the previous class. So if the components doesn't follow the RFC standard, okay, then we call them as non-SNMP managed object. Okay, those who doesn't, for example, I think it is RFC 1155 that your SNMP follows. So if the devices don't follow RFC 1155, then they will be called as non-SNMP managed object. So how do I manage an object which doesn't follow the SNMP protocol? So then I should have a proxy server. That proxy server will help in conversion of your non-SNMP managed object into SNMP manageable object. So your SNMP can manage the objects that follow your RFC standard. Okay, the request for comment. So if you remember, we saw RFC in the last class. RFC has got two things. One is standard protocol and second one is for your information. So for your information will contain all the details that is the data that is that or any component that is introduced new to the network. Okay, if you want to know anything about the network, then you can use the FYI for your information. And standard will have a protocol like thing. So this will be your RFC was not a standard when it was into usage. So to make it as a standard, they had it as standard RFC. So it will be like a protocol. So if your device doesn't follow RFC SNMP protocol, then it can be managed with the help of a proxy server. So this proxy server will convert all your non-manageable SNMP objects into manageable SNMP objects. For example, assume that I have a hub. Okay, that is not as per your RFC standard. So then this hub, I will have to convert it into SNMP protocol, SNMP managed object. So that is done by your proxy server. So your proxy server will convert non-manageable SNMP objects into SNMP manageable object. So that is regarding with your organization model. So here, as I told you, you will have multiple managers, and to manage those multiple managers, we can have NMS. NMS is your network management system. So this NMS can act as a manager as well as an agent. For example, if you see in this picture, just this RMON, okay, remote monitoring. So what it is doing, it is doing the work of monitoring the network. It is counting the number of packets that are in and out of your network. So monitoring itself is the work of a manager, right? So now I can say this RMON, okay, remote monitoring is working as a manager. For example, if this has to give the data back to the SNMP manager, then this RMON will act as an agent. So when this is monitoring the network traffic, this is acting as a manager. When it is giving back the details to the SNMP manager, it becomes an agent. Okay, so this is how the SNMP systems will work as a manager and as well as an agent in few situations. So when RMON is monitoring your network traffic, it becomes a manager. when it is giving back whatever details it has monitored. Okay, so for example, at a particular time, okay, at 10 a.m., so number of packets that the network has received is 256. The number of packets that it has transferred is 500, something like that. So this information, whatever it is giving to the SNMP manager, then that at that point RMON acts as a agent. Okay, so as component of an SNMP, it can act as a manager and it can act as an agent depending on the situation. So this is what is NMS as manager and agent. So your network management system can act as a manager and it can act as an agent depending on the requirement. Not all the managed objects will act as manager and agent. Few system components can act as both. Okay, not all the components of your network system will work like it. So in our example, remote monitoring is work as an agent and it can work as a. So that is what is said in this diagram. Okay, your manager can act as an agent at some point of time and it can also act as a manager as well. So SNMP manager can be an agent as a manager in few situations, not in all the situation. Okay, for as I told you, if you want to monitor the traffic, so remote monitoring can act as a manager at that point. So if it is going to give back the data to the manager, see why we had a remote monitoring is to avoid the burden on the SNMP manager. SNMP manager is managing all the components, and in addition, if you want it to manage the network traffic also, then it becomes a burden on the SNMP manager. So to avoid that, we have remote monitoring. So remote monitoring will do the work of monitoring the network traffic, number of incoming packets, number of outgoing packets. So in that, when it is monitoring the network, it acts as an agent. So it is just giving back the details to the SNMP manager. So when it's giving back the details of monitoring the network traffic, then it acts as an agent. So when it is giving back the details that it has monitored, then it is acting as an agent. When it is doing a monitoring, it is a manager. When it is giving the data back to the manager, then it is acting as a agent. So this is how your network management system can act as both manager and agent in few situations, not in all the cases. The next one is the information database that we have. So as I told you, we'll be seeing about managed object, what are the syntax for structure of management object, and information database. So here you have two kinds of database in SNMP. One is information about the object and the second one is values of the object. There is a difference between them. Information about the object and values of the object. The information about the object is nothing but your MIB. Okay, so MIB will contain all the information regarding the object, like name of the object, the semantic rule, the syntactic rule that it follows to transfer the data. So MIB is nothing but information about the object. So the information about the object will be nothing but the name of the object, syntactic and semantic information about the object. And the second database is nothing but the value of the object. So for example, value of the object can be like what is the speed in which it can transfer the data. Something related to the specific device. That is the value of the object. So MIB will monitor the information about the object. Okay, so information about the object is maintained by MIB. So values of the object, it will be separate. So information about the object is nothing but name of the object, syntactic and the semantic rules that we have when the devices transfer data and communicate with the different components. So these are the two kinds of database. So second one, as I told you, it is associated with the values of the database. sorry, values of the object. So first one is information about the object, and second one is values of the object. So information about the object is your MIB. So next, so till now we saw about the organizational model. So in organization model, we saw two-tier architecture, three-tier architecture, and we saw the information base, that is database. So if you could remember the structure which I gave, how SNMP follows the five messages, okay, the five messages, how they follow, and how what will be the where the SNMP works. So SNMP works at the application layer, right, of your OSI model. So there in that place, in SNMP manager, we have this database diagram. Okay, symbol to indicate that you have a database, because MIB physically exists. Okay, MIB is physically existing, so that is maintained by the manager. And the second database that I was telling about, which is your value of the information, sorry, value of the object, that is like a software. It is maintained both by the manager and both by the agent. So manager and the agent will have the second database that I was telling about, which is your value of the object. Information about the object is MIB, which is maintained by the manager. So this is what we saw in the organizational model. The second model that we will see is your informational model. So informational model tells you about the MIB that I was telling about. So MIB is nothing but name of the object, semantic and syntactic structure in which the data is transferred between the objects. So information model deals with SMI, structure of management information, and MIB. So the specification and organizational aspect of managing the object is maintained by SMI. So as I told you, this is done in RFC 1155. Okay. Next one is your MIB. So MIB specifies how the managed objects are grouped and relation between the management objects. So how they communicate, all those things. So this is given in RFC 1213. So you need to know the RFC standard in which all these things are maintained. So SMI is given by RFC 1155 and MIB is given by RFC 1213. So RFC is request for comment. So next one is structure of management information. So SMI will contain managed object. So in terms of the type and instance of the object. So if you could remember the diagram, this diagram which we saw in the previous class also. So each object will have type and instance. Okay, so this type contains the name, syntax, and the encoding. So how the object is named, which syntax it follows to transfer the data. So when you transfer the data, which kind of encoding, because you cannot send the data as a plain structure. You need to change it into a format such that others will not tamper your network and read the data. So this is what is given by object type. So as I told you, your object managed object consists of object type and object instance. So a managed object can be anything that is available in your network. It can be a physical entity or it can be an abstract entity. Physical entity is like the device, hub, switch, router, printer, all the devices that we have in the network. So it can be abstract, meaning, for example, internet is an object itself. Okay, whatever we are using, right, internet, world wide web, it is considered as an object as it is. So because without the internet, we cannot transfer the data over the network. So we need an internet, a medium through which your data can be transferred. So a managed object can be either a physical entity or it can be an abstract. Abstract means you are hiding it. You don't show the actual functionality of it. So for example, if you have internet itself as an object, so the name of the object is internet and the ID of the object is 1.3.6.1. So this is predefined. So this object identifier, if you could see, I've written it with capitalized letters, all in uppercase. So which means that this is a keyword. So where you have this keyword is in your ASN, abstract syntax notation. So as I told you, your object type will specify the name, that is syntax, and then encoding. So this syntax that we have. Okay, so this is given by ASN. So this name object identifier is given as the internet. So object identifier is internet, and it is using the keyword object identifier of ASN1, and value of it is 1.3.6.1. So we will see what this 1.3.6.1 is. For example, as this is for an example, so anything inside your network can be a managed object. It need not be always a physical entity. So this is internet MIB. Okay. So information about the internet. So internet is your name of the object, and the value that this object is having is 1.3.6.1. So each object will have type and instance. So this is what your SMI deals with. Okay, SMI and MIB deals with the object type. So how we can name this object? So we will see that. So a managed object will have type and instance, right? So each type will have name. So name is uniquely defined by a descriptor and an object identifier. So here this internet is nothing but your descriptor, and this is your object identifier. So every managed object will have object type, and in object type we specify the name of the object. So name of the object will have two components. It is defined by the descriptor and object identifier. For example, the internet, that is what we saw, right? So internet, its object identifier is 1.3.6.1. The internet is your descriptor, and this is your object identifier. So for example, here IP address table, okay, which contains all the IP addresses in a table. So its descriptor is IP, and its value is IP20. Okay, so its descriptor is IP address table, and its value is IP20. So every object name is uniquely identified by a descriptor and by an object identifier. So your descriptor is a mnemonic, and it has to be unique. It begins with a lowercase. So here the second word, okay, first character can be uppercase, but always it begins with a lowercase. And your object identifier is always written in capitalized letter to indicate that it is a keyword of ASN. So this is about the name. So this was the example that I was talking about. So internet is your descriptor, and the object identifier is 1.3.6.1. So this is how we write the object type. Okay. So this ISO org DOD1. So what is that? So that is nothing but the different objects that you have in internet. Okay, so you have directory, you have management, you have experimental, and you have private. So directory is nothing but a directory that OSA model gives you. Okay, first is your root, then is your subdirectory or subfolder, then again your subfolder, and then you have the original path, right? That is what is your directory. So when you go and search on your Google Chrome, we give www.google.com. So then you search something, then you have a page. In that page, if you have to navigate to somewhere else, so that you do, right. You can see on the address bar, you have the directory structure. So that is given by the first one. So first one, so this ISO, okay. So this ISO gives you the directory structure. So second one is management. So any object in internet will have four components, as I told you. First one is directory. The second one is the management. So this is identified by your IETF, Internet Engineering Task Force. So this will tell you how the devices are managed. Okay. So next, third one is experimental, which is used to define your objects. And the last one is private. So how we are using them is in different way. This can be written in different order. ISO is 1. See, this 1.3.6 is written like this. ISO, then within bracket you can have 1. And this is your, what is that? Just a minute. Management. Okay. So management is org. Okay. You can have com, ritchennai.edu.in. So anything like that. Or wipro.com or tamilnadugovernment.org, something like that. Some management. And then this is your enterprise and this is your private. So I'll tell you about enterprise and private later on. So first, this one is your ISO standard directory. The next one is management. This is your enterprise and this is your private. So this 1.3.6.1 can be written in different manners. So ISO 1, then the standard, then DOD, then internet. Or you can have 1361 written as it is. Then you can, without any the number specification, you can write ISO standard, DOD, internet, or ISO standard, DOD 6 of internet 1, anything like that. So these are the different ways in which you can represent an object. So each object will have name. So the name can be uniquely specified by descriptor and object identifier. So this descriptor is unique and it is always written in lowercase. Object identifier is a ASN keyword and this is how you represent the values of that object identifier. So this is regarding with the internet MIB object. So you can see the structure here. So this internet, okay. So 1.3.6.1, this is how it is written. So directory, management, experimental, and then private. So this directory is your OSI ISO model, and then this management is whether it is ORG or COM or EDU, anything like that. So experimental and private, it depends. This private depends on your vendor. So how it depends on your vendor is, so this is your internet, right? 1.3.6.1. So then in that I have this private, and in private I specify the enterprise. So the enterprise are nothing but the vendors that we have. If Cisco, HP, 3Com, Cabletron. So these are the different vendors that we have. So this is the small structure for how a different vendor, the MIB will differ. Okay. So what is this 9, 11, 43, 52? So these are nothing but the numbers which are given by your IANA, Internet Assigned Number Authority. So this authority is responsible to give all the numbers like the version number for a software. Like SNMP has got version 1, 2, 3, right? So then you have this Cisco has got a directory value 9, HP has got a directory value 11, 3Com has got 43, Cabletron has got 52. So these values are given by IANA, Internet Assigned Number Authority. So this is a small tree-like structure, how this internet will differ on depending on the enterprise. So I can write it as 1.3.6.1. So in private 4, if I'm using Cisco, I'll write it as 4.9. For example, I don't know whether I've given that. Yeah, I didn't give that. The next class I'll show you the example for a different vendor how you write this internet MIB. So your internet MIB is an example that we have chosen to represent your object type. So every object will have type and instance. So first we have seen only about the name of the object. Still we have the syntax and encoding to complete your information model. So information model deals about your managed object. So every managed object will have type and instance. So MIB and SMI deals with the object type. So in object type, you have name. So name is uniquely identified by descriptor and object identifier. So descriptor is a mnemonic which is unique and it will be written in lowercase letters. And object identifier is the keyword that is specified by ASN. So this object identifier will have a tree-like structure. So how we name them is, we have taken an example of internet MIB. So this internet MIB has got 4 objects, which is your organization, management, enterprise, and private. So we represent these different uh, what to say objects together to write your internet MIB. So in next class we'll be seeing about the syntax and encoding of ASN, which we have already seen for the first unit. So in first unit itself I told you this ASN, right? So when I was taking this ASN I told you this will be useful in your SNMP. So how I'll just give a quick glance of what ASN is in the next class, and how the encoding is. So what are the keywords that we use, what are the macros that we have, and what is the encoding structure that it follows. So B, basic encoding structure, that is what your ASN follows. So this is about your managed object. I have not completed your information model completely. I've completed only the name part of your object type. Still, we have the syntax and encoding, which deals with your ASN. So, since time is up, I don't want to repeat that again. So, I'll just give a quick overview of ASN in the next class. Clear? So, if you have any doubt, you can ask me. So, do you have any doubt?